Alright guys, welcome back to the channel. So today we'll be going through some past questions on limits, right? So let's try our first example on it. So it's question 1. We are told that if the limit of f of x as x goes to a is equal to capital A, then what is the limit of c times f of x? So now in this case, note that c is a constant, right? So from the first video, we saw that the limit of a constant, say c, f of x, as x goes to a, is equal to the constant multiplying the limit of f of x as x goes to a. Good. So now here, we just have to use this rule to find our answer. Now, we know that limit of f of x as x goes to a is equal to capital A, and that's this a given. So what it means is that this whole expression is now equal to a. Then what will be our limit? Then our limit will just be c multiplying a. So that's limit as f of x goes to a, c times f of x is equal to c a. That's option D. So D is the correct answer. So let's move on to question 2. With question 2, we have to find the limits as s approaches 0 from the left. So now let's draw a number line C. So now let's say 0 is here. Now what are the values on the left side of 0? That's, we have these points right here, right? So these points in here are on the left side of 0. So we have some points like minus 0.001. All these are on the left side of 0. Minus 0.0001. We also have some points like minus 0.5 and so on, minus 0.6. All these are on the left side. All these are points within this area, right? Good. So now, by definition, absolute value of x is defined to be x and minus x. Is x if x is greater than 0, and it's minus x if x is less than or equal to 0. So now let's say we have to find the absolute value of 5. So now in this case, your x is 5, right? Now here, note that 5 is greater than 0. So its absolute value will just be equal to 5, right? Based on this definition. Now let's say we have to find the absolute of minus 3. So here, minus 3 is less than 0, right? So the absolute value will be minus x. So we are going to have minus x is minus 3. So here is going to be minus 3. So that's 3. Right, so now that's the definition of the absolute value. So now we can now solve this example. Let's pick some points on the left side of 0 and see what we're going to have. So now let's pick, let's say 0.5, right? So if we pick minus 0.5, we're going to have minus. So now let's pick some points on the left side of 0 and see what we're going to have. So we are going to have limits as x approaches 0 from the left. So let's pick some points on the left side of 0 and see what we are going to have. So let's pick a point like, let's say minus 0.5. So we are going to have the absolute of minus 0.5 divided by 0.5, right? Now, based on the definition of absolute value, minus 0.5, its absolute will be 0.5, right? Then divided by minus 0.5. So here is going to be minus 1. Good. Now let's pick a point that's somehow closer to 0. So let's pick, let's say 0.03. So minus 0.03 rather. So we find the absolute, because based on this definition, so we find the absolute of this guy divided by minus 0.03. So the absolute will change to positive, so you're going to have 0.03 divided by minus 0.03. So this will give us 1. Sorry, minus 1 rather. So this will give us minus 1. Right. Now, as we can see, when we pick some points closer to 0 on the left side of 0, our answer is going to be minus 1. Right. So now the limit is minus 1. So let's try our third example. So we have to evaluate the limits of the square root of 25 minus x squared as s approaches 4. Okay, so here note that the square root function is not defined when the value inside it is less than 0. So with our third example, we have to find the limit as s goes to 4 of square root of 25 minus x squared. So here, when we substitute in 4 inside the square root sign, we won't get a negative answer, right? So now here we are good to go. So we can just substitute it straight. So you're going to have square root of 25 minus 4 squared, and that will give us 25 minus 16, and that's going to give us 9, right? So that's square root of 9, and that's equal to 3. Let's try some more examples. Now with question 4, we have to find the point where the function f of x will be discontinuous or not continuous. So now here a function is discontinuous when the denominator is equal to 0, right? So if the denominator is equal to 0, then the function will be discontinuous, right? So we have f of x to be f of x is equal to x squared minus 4 divided by x minus 2, and we have to find the points where this function will be discontinuous, right? Now this function will be discontinuous when the denominator is equal to 0, right? Okay, what value of x will make the denominator goes to 0? Now let's check. We have the denominator to be x minus 2. So now at what point will x minus 2 be equal to 0? That's when x is equal to 2, right? Because if x is equal to 2, we are going to have 2 minus 2, and that's 0. Then this expression will now become, let's say, x squared minus 4 on 0, and this will be undefined, right? Good. So here our answer will be when x is equal to 2, then this function will be undefined. So this is how we are going to solve it. We set the denominator to be equal to 0. So we are going to have x minus 2 is equal to 0. That's x is equal to 2. So at x is equal to 2, this function will be undefined. That's the denominator will go to 0, making the function undefined. So here our option is option A. Now let's solve the fifth example. The fifth question says that which of the following statements is not true for a function to be continuous at x naught? Good. So now we are back to continuity of functions. So now for a function to be continuous, these are the rules that the function must follow. 1. The limit should exist. So here we are going to say that the limit at x0, because we have to find the point of discontinuity at x0, right? So now the limit as x goes to x0 of f of x should exist. So now rule number 1 says that the limit as s goes to x0 of f of x should exist. That's the left hand limit should be equal to the right hand limit, right? That's when we say that the limit exists. So that's 1. Point number 2, the function value of f at x0 should be defined. That's the function value at x0 should be defined. And now this function value should be equal to the limit at that point, right? So that's 3. So limits of f of x as x goes to x0 should be equal to the function value at x0. Then we say that the function is continuous at the point x0. So now here we have to find which of the following statements is not true. That's which of the statements is false. Now A says that f of x is defined at x0, and that's true. B says that the limit should exist. That's true. C says that the limits at x0 should be equal to the function value at x0, and that's true. But D says that the limits as x goes to s0 of f of x should not be equal to the function value at x0, which will make the function discontinuous. But at this case, we want which of the following statements will make the function continuous. So which means that D is wrong, because if this case is true, then the function is not continuous. That the function is discontinuous, right? So our option is option D. That's the false answer to question 5. Alright, hope this video helps. So this is a past question that I saw online, and I decided to go through with you guys.